Morning, everyone. Hope you guys had a wonderful weekend and enjoyed the freezing cold weather while I was in sunny weather. All right, so today we are going to learn about absolute value functions, and this is known as the parent graph right here, okay? And notice that it's in the shape of a V, so what I always tell people is V for absolute value, okay? And notice, the program that I use on the computer doesn't do arrows, but this goes on, okay? So the domain for absolute value is always negative infinity to infinity, no matter what type of graph we have. And then the range will change, but on this parent function, the range is 0 to infinity. So notice that we start at 0, 0, and the y value is 0, and we go up, so it goes to positive infinity. Okay, the standard form for absolute value is a times the absolute value of x minus h plus k, where hk is the vertex, okay? Vertex is the starting point, it's the point in the middle. So that is the standard form for absolute value, and then this is known as the parent function. Okay, if we look at this example here, the red line is the parent function, and then the blue line is a translation, okay? Notice that we went up 2, and this number outside here is a positive 2. Then if we take a look at the green, notice that we went down 3 from the vertex, and this number outside the absolute value is also a negative 3, okay? So what is happening to the vertex? Which directions did it go? Okay? So hopefully you would conclude that the vertex is moving up and down. Okay? And then the question asks, if k is positive, okay, and then remember that k is on the outside of the absolute value, so this is k. If k is positive, which way did our graph go? So the blue graph from the red graph went up. If k is negative, then our graph goes down. So in the equation, you will see plus k for going up and minus k for going down. Okay, so k controls if the graph moves up or down. Okay. All right, let's go to the next page. Okay, and here's our parent function again, the red line. Okay, this time let's look at the blue function. Remember that the ordered pair is 0, 0 from where we start. So how did the blue line change from the red? Well, it went to the right 2. Okay, and inside the absolute value we see x minus 2. And then the green function from the vertex went to the left 3, and notice that on the inside of the absolute value we have plus 3. Okay, so how is the vertex moving with respect to the original parent graph? Okay. And hopefully you would say the graph is moving left and right. Okay, so here's where it gets a little confusing. It says if h is positive, then the vertex moves which way? So you got to remember that the actual standard form is x minus h plus k. So in the blue line here, since we're subtracting 2, we're actually subtracting a positive number. Okay, so therefore we are going to the right. So x minus h is what you would see in the equation. Okay, and then if h is negative, what happens is you subtract a negative number, which is why you see addition inside the absolute value. And we go to the left. So one way some people just think about it in very basic terms is that on the inside, okay, you go the opposite of what you see. So if you see a minus sign, you go to the right. If you see an addition sign, you go to the left. Okay? When we're working outside the absolute value, if it's positive, it's positive. If it's negative, it's negative. This only applies to the inside. Okay. All right, let's take a look at another investigation. So the original line is our red one, okay? And then here we have a blue one. Notice that the only thing different is this negative on the outside here. So what happened to the graph? The graph flipped, okay? So if A is positive, the graph opens up. If A is negative, the graph opens down, and we say that it reflects over the x-axis. Okay. So if A, which A is the number in front of the absolute value that's attached by multiplication, if A is positive, our graph opens up. If A is negative, our graph opens down. Okay, which will change the range, which we will talk about in a bit. All right, let's go to the next page and look at one more investigation before we conclude everything, and then we will start graphing. So the original graph, once again, is the red one. Okay. Then notice that the blue one is inside, and there's this number 2. And then this green one is a lot wider, and it's 1/3. Okay. So the blue, we would say, is narrower than the red one, and the green, we would say, is wider. So what can we conclude? Well, that when the absolute value of A is greater than 1, then the graph stretches vertically. Okay. So another way we say that is vertical stretch. So I get taller when the absolute value of A is greater than 1. If the absolute value of A is between 0 and 1, and be careful here, sometimes people will say, well, it's a fraction, then it's going to be wider. Well, what if it's 4/3? 4/3 is greater than 1. So it has to be between 0 and 1. Then the graph shrinks. It gets wider. So it's a vertical shrink. Okay, or you can think of it as you get shorter. Okay? When A equals 1, that's the parent graph. All right. Graphing. In order to graph, we need to know what the starting point is. The starting point is the vertex. So once again, here's the original equation. Okay, we start the graph at the vertex HK. Okay, so looking at this one, what would the vertex be? Okay, so this is your H value out here. This is your K value. So we would say that the vertex is 3, 0. Remember, it's the opposite on the inside. Okay. In example 2, Luke, what would the starting point be? Good, you answered -4, -1. Okay, so on the inside of the absolute value, you do the opposite. So since you see +4, then that means we're actually going to the left 4. And then on the outside of the absolute value, it stays the way it is. Okay. And then finally, what did we get for the vertex? In other words, the starting point for number 3. Good. 0, 4. Okay. We didn't see a number on the inside of the absolute value, so then therefore H is 0, and then we have the plus 4 on the outside. All right. Okay, so we need to talk about the axis of symmetry and the slope. So the axis of symmetry is where it splits that V in half. Okay, and the axis of symmetry is always whatever the h value of the vertex is. Okay, so that ordered pair, HK, that x value, that is the axis of symmetry. It has to go through the middle, and you always have to write the axis of symmetry as an equation of a line. So if you don't write x equals whatever the number is, I will take a point off. It has to be written as an equation of a line. Okay, and then A is kind of like what we know as the slope. Okay, you graph A like you would graphing a line, but then you create a V. So you have to go in both positive and negative direction to create a V. Okay, let's go on to the next page. So remember that the general form, we've written this a bunch now, is A times x minus h plus k, where hk is the vertex. Okay. And then h shifts the graph left and right. K shifts the graph up and down. A itself affects the graph if we open up or down. If it does open down, we say that that reflects over the x-axis. And then the absolute value of A affects the vertical stretch or shrink. Okay. We're not going to do this today, but tomorrow these are the descriptions of shifts. So tomorrow we're going to describe how our graph changes from the parent function, and we're going to use these words that we just listed. All right, so we're going to go ahead and take a look at our problem. We're going to find the vertex. You're going to find out what A is, and then graph also the axis of symmetry. All right, so the vertex for this first example is just 0, 0. And then A equals a positive 1/3. So that means my graph should open up. And then the axis of symmetry is just whatever the x value of the vertex is. So x equals 0. And once again, make sure you write it as an equation of a line. So we're going to start at the vertex at 0, 0. And then we need to graph 1/3. So we need to rise 1 and run 3 to make a V. So I'm going to rise 1, run 3, rise 1, run 3. And then do this on the other way to make the V. So rise 1, run 3, rise 1, run 3. Okay. And on these ones, you want to graph at least 5 points. Okay. And then you would use a straight edge, just like we talked about in the previous video, to make sure your lines are nice and straight. Good thing you have a thing called an ID that can make the straight edge for you. Okay. All right, there's example number 1. Let's go ahead and take a look at 2. So the vertex is -4, -5. Okay. And then the axis of symmetry is x equals -4. It's whatever the x value of the vertex is. And then A equals 1. So once again, my graph is going to open up. If you're not sure where the A value is, it's the number in front of the absolute value. So if you don't see a number there, we know that A is 1. So we plot our point, -4, -5. And then we're going to go up 1 and to the right 1. And then do the same way to the left so that make a V. Okay. And of course, you would use a straight edge. This program does not allow me to make straight lines, which drives me crazy, but make sure your lines are straight. All right, last example. So the vertex is 3, 4. Axis of symmetry is x equals 3. A equals -2, so my graph needs to open down now. Okay, so let's go ahead and go over to 3, 4. Okay, and since A is negative, I need to go down, make my V go upside down. So I'm going to go down to the left and right 1, and then down 2 again. Okay, don't worry about the X and Y tables off to the side. We're just going ahead and teaching you guys how to graph by the A value, so you don't need to worry about the tables. Okay. All right, so your homework for tonight is worksheet 2, and then I will be back tomorrow to talk about the second day of absolute value that will deal with domain, range, and then also the shifts. I hope you all have a wonderful day, and please use homework time wisely. Thanks. Bye.